Okay, so this is the example of the noisy data. Why it is noisy? Because we can see that first the postal code. The postal code should be in numbers, but there is Y. And then we call this is missing value. And this is noisy because it is out of the range. It is out of the range. Maybe we can check also if it is out of the range and it is outliers in terms of the distribution. Okay? So when you check the distribution, maybe many of people are in between 0 until 100, but only some people who have 455 and 222. So because it is outlier, then it is noisy. And we have the dependency. What is the dependency? This code has dependency with the city. So that's why there are many bad data, or there are many noisy data if you remove this dependency. That's the reason that the Korean government always put the system, the data scrubbing, to maintain the dependency between the postal code, the address. So we need to check this uniqueness rule. That's what I mentioned before. The uniqueness rule means if we have the postal code 17035, it means this is the Yongin, not Seoul. It should be unique. And we have the consecutive rule. What is consecutive rule? One data will follow another data and will follow another data. So have you ever been filling a questionnaire? If you fill the questionnaire, like say, they ask you, what is your nationality? Okay, you choose Korea. Okay. And where is your address? Then there will be another option because you live in Korea and your nationality is Korea. When they ask you your address, there will be maybe the option of your province, Gyeonggi-do, Gangwon-do, or Busan Gwangyok-si, Seoul Takpyeol-si, Daejeon. So there will be option. Once you choose Gyeonggi-do, there will be the cities in Gyeonggi-do, Suwon-si, Ansan-si, Yongin-si. So it is the consecutive rule. When you select one option, it follows another option that belongs to that option. So if you choose Yongin, then there will be 3 different districts. Only Cheongu, Sujigu, Gyeonggu. Because it is the consecutive rule. So that's the example of the consecutive rule. What about the null rule? Maybe this is also belong to the null rule. In some cases, people do not want to share their gender. Okay? So in some countries, they respect the privacy. So you can say that I do not want to share my own profile. I do not want to share my gender. That's possible. In that case, there is a null rule. If it is a null rule, then this is not noise. But if there is no null rule, we need to consider this is a noise or this is the missing value. So in the data cleaning as a process, there will be some kind of terminology. Okay. We call it, this is the data migration and integration. And there are some tools. We call it the data migration tools. And it allows transformations to be specified. ETL, extract or extraction, transform, transformation, loading. So it allows users to specify transformation through a graphical user interface. So the extract means we will extract from some database. It might be the CRM, the customer relationship management, or it might be from the ERP, enterprise resource planning, or from the LOB, the logistic data. And then when you transform the data, there can be some noisy data or maybe some missing data, and you can transform it. Maybe you want to remove it. You want to change the data. You want to normalize the data. And you want to load it into one database. So usually we will do this ETL process, and once we have this data warehouse, we will use this data warehouse as the data analysis. So we will learn more specific about the data warehouse. So the data cleaning will be in this part. So we do hope that all cleaning happens before doing the analysis. Now, we already know about the missing values and the noisy data. Another issue for the pre-processing is data integration. Integrate. We call it integrate. Data integration, it combines data from multiple sources into a coherent store. So as I mentioned to you, we can have the ERP data, we can have CRM data, or we have another database. So you want to put into one database. So you want to integrate into one. There are some ways. Okay. First, we can do the schema integrations. Schema means if you learn about database, there will be table. Okay, the table 1 and the table 2. So if the table 1 and the table 2 have some similarities, let's say I want to combine the table A, which has the attribute customer ID, and I want to combine with the table B, which has the customer shop. Sometimes in the company or the database developer, they put the attribute with shop to identify as the identity ID. But actually they are the same, ID and shop. So we can integrate between those two tables. It means we want to integrate the metadata from different sources. Maybe this is the data from the company in Busan. This is the customer data from the company in Seoul. So they want to combine it. They want to integrate it. But they just have different attribute name. So we can do the schema integration. Or we can have some entity identification problem means the value Okay. Let's say identify real-world entities from multiple data sources. For example, do you know Bill Clinton? Yeah, he was a president of US. He was a US president, and actually, yeah, whenever the media wrote his name, media always said he is a Bill Clinton. But actually, his full name is Bill W. Clinton. Sometimes people use the name William Clinton. Actually, they are the same, but the value are different in the database. So that will be also a problem. Or Korea have also issue with the alphabet. Let's say the Moon Jae-in. Maybe some news they put the president name Moon Jae-in like this one, or maybe some people say like this one, or some other people use this way. So it is not consistent. When you want to integrate, there will be some problem. Okay. So we need to detect and resolve these data value conflicts. For the same real-world entity, attribute values from different sources are different. And you need to be very careful as well if we can have different representation or maybe different scales. In Korea, you will measure the length. For example, the length of this monitor in centimeter. But if you go to British or if you go to US, maybe they will measure this length with inches. So that will be different. If you want to measure the height, we in Korea use centimeter, 160 centimeter. But if you go to US, they will use feet. What is your height? Oh, I'm 6 feet 25 inches. So the attribute name is the same, height, but the metric is different. So we need to have the consistent data integration. Handling data redundancy. So we can handle the redundancy here. Redundant data occurs when integration of multiple databases. Maybe you can see easily if we have only several attributes, it is easy. But if the data or the attributes are many, it will be more complicated when you want to integrate the data. So we can check the redundancy by object identification. The same attribute or object may have different name in different database. So maybe, for example, in one database, you call the attribute name as sex. But in the other database, you mention the attribute name as gender. Okay. When you combine, there will be column sex and there will be column gender. So you need to identify. If those attributes have the same values, then we can remove it. We can remove one attribute. Or derivable data. One attribute may be derived attribute in another table. For example, annual revenue. Annual revenue, annual, it means year, yearly revenue. If we want to know the year revenue, it means we will collect every month revenue. For every month revenue, it will be collected from the weekly revenue. For the weekly revenue, it will be from the daily revenue. So if we have this kind of derived attribute, so we need to check the redundancy. Redundant attributes may be able to be detected by the correlation analysis and covariance analysis. You already learned the correlation analysis. Okay. For the covariance analysis, I think I will not discuss more because I think it is enough to see from the correlation analysis. Careful integration of the data from multiple sources may help reduce or avoid redundancy and inconsistency and improve mining speed and quality. Okay, this is just a revisit. Okay, just want to review again about the chi-square. The chi-square is the correlation analysis for the nominal data. And the larger the chi-square value is, the more likely the variables are related. So last time, as maybe you still remember, that our example shows the values about 500 something. Okay? So at the time, the chi-square value is 500 something. So I need to clarify that there is a chi-square distribution table. So it depends about how many attributes you want to use, how many values you want to use, and then there is a table. If the value is above the particular value in that table, then it is significant, or we call there is a high correlation. The other correlation analysis, we already learned that the correlation analysis with the person product moment coefficient is for numeric data. Okay. So we already learned also with the R value. If R value is higher than 0, then it is positively correlated. If it is less than 0, it is negatively correlated. If it is 0, then it is independent. Okay, I would like to explain this data integration. Maybe this is just a simple integration. I already shared there are 4 files of CSV in the e-class. We have the employee salary.csv. We have the employee supervisor data. We have the employee date data. And then we have employee department data. Okay, so we have 4 data sets, and we would like to combine those data. Okay. First, we need to know the data set first. The employee salary, we have the employee name, we have the employee salary, and some allowances. Maybe this is about the incentive. Okay. So the salary is the basic salary plus the allowance. Employee supervisor, we have the group or the department name, and then the supervisor name. If the group is accounting, then the supervisor is Carly. If the group is engineering, the supervisor is Guido. If the group is HR, then the supervisor is Steve. We have the data employee department. Bob belongs to accounting. Jake belongs to engineering. Lisa belongs to engineering, and Shu belongs to HR. So the employee salary and the employee department, it seems, yeah, they have the same attribute, okay, but here they use name, here they use employee. In the employee date, it shows that the attribute name is employee, and then the hire date shows that the Lisa has been hired on 2004, Bob has been hired on 2008, and so on. So we have 4 data, and we want to combine those 4 into one table so you can easily analyze it. We want to integrate it. So how we can integrate with orange? For easy things, okay, I give you the files. There is a file that I share to you in the e-class. The file name is practice merge. So you can open your orange. You can open, okay, or if you want to make it easy, you can just drag the files and drop it into the orange. So once you drag and drop, then it will open the flow automatically. So I already fill in every of these files, file with the data that I shared to you, the employee date, the employee department, the employee, the employee salary, and the employee supervisor. Okay. Okay, I'm sorry. This one, actually, you can change the name, okay, to make it more clear. You can rename. Let's say this is file, and you want to express this. You can press F2. Yeah, rename. And maybe you want to express employee salary .csv. And then for this file, it is the employee supervisor. So you can rename employee supervisor .csv. So by giving the exact name, it will be easier for you to understand the flow. And then you can see merge. Okay. Let's see. First is the file employee date. Employee date has 2 attributes, hire date and employee name. So if you open this, we have the hire date and employee. We want to combine the employee date with the employee department, employee categorical features and group accounting engineering HR. If you look this one, Bob belongs to accounting, Jake belongs to engineering, Lisa belongs to engineering, and Shu belongs to HR. So you can merge those 2 data. How we can merge it? We want to concatenate the tables. Concatenate means merging 2 tables. The first table, we will use the row with the column employee. And for the second table, we want to also use the column employee. Then after you merge the data, you will get the combine. Okay. So the hire date, employee, and group. Now it is in the same table. Next, I want to combine with the employee salary. So we have the name, we have allowance, and then we have the salary. I can combine. Again, I want to concatenate the tables. So there are two tables I want to combine. And the first table, I would like to use the column name. And the other table, I would like to use the column employee. So actually you can choose what is the proper column for the combination. So here I know that name represents the employee. So I use this one, and then we can make the whole data into one big table. So employee, Bob, Jake, Lisa, and Hugh. And you can see that's also next. It is redundant. But later you can remove it if you feel it is not necessary. For now, we can just learn about the merging. We have salary, allowance, name, hire date, employee, and group. So I would like to teach you also one thing about the aggregate column. What does it mean by the aggregate column? Let's say you want to do something to combine two attributes. I know that the salary and the allowance can be combined. So I want to know the total salary. The total salary will be salary plus allowance. So I can just click on those two attributes, salary and allowance, and I can choose the operator. The operator can be many options. You can choose sum, or you can choose product. Product means multiply. Or you can check what is the minimum among those two values, or what is the maximum among those two values. What is the mean? What is the variance? What is the median? And so on. I would like to do the summation, and then let's create a new variable, total salary. So here we will have a new column. After we merge and after we do the aggregation, we have a new column, total salary. The total salary is the summation of the salary plus allowance. That is the function of the aggregate columns. And for the last one, I would like to check with the employee supervisor. So I want to know who is the supervisor of each of the employee. As you can see here, the supervisor it belongs to the group. We have only 3 groups, but we have 4 employees. Now, how can we merge it? In the merge data, because it is different, we need to append column with extra data. So it is not about the concatenate table. So there will be another way, like the find matching pairs of rows, but we are not finding those pairs. Okay. So in this case, I would like to use these append columns for the extra data. So by using this merging, I can see the supervisor. It is based on the group. So accounting, the supervisor is Carly. In engineering, the supervisor is Guido, and the HR, the supervisor is Steve. So we still maintain the data of employee. Okay, so this is about the merging or the data integration. Okay, yeah, those are the details. Any questions? Yeah, I think this is just a very basic data integration. We still have some time, so let me move to the next PowerPoint, and we are going to discuss about the data preprocessing number 2. So we already learned about the data cleaning, and we already learned about the data integration. Now this section will discuss about two things: the data reduction and data transformation. The data reduction. What is the meaning by data reduction? The data reduction means we want to obtain a reduced representation of the data set that is much smaller in volume, but yet produce the same or almost the same analytical results. I can say something like what I explained before. If we have 1 million data, it is very big. How can I reduce it to 1,000 data? And I want to get almost the same result. So I can do with data reduction. We call it data reduction. We want to reduce. We want to reduce. Why data reduction? A database or a data warehouse may store terabytes of data. You can have a very good computer with very big hard drive, but still there are limitations. So yeah, we need to think. Complex data analysis may take a very long time to run on the complete data set. So I had been working with some companies. They want to analyze the sales data in 1 year. So you can imagine in 1 year, how many data are there? So it's impossible to analyze all the yearly data. So we need to reduce the data so we can analyze at least represent the 1 year data. So there are some strategies for data reduction. The first is dimensionality reduction. You still remember? Dimension. 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 Other words can be feature. It can be column. It can be field. It can be variable. It can be attribute. Okay. Those represent the same name. Okay. We call dimensionality reduction. It means we want to remove unimportant attributes. So we want to remove the column. So many people say it is feature selection. So if we have 6 columns, How can we reduce it into 4? So we call this is dimensionality reduction. There are some ways. Okay? We will learn about the wavelet transform, PCA, and maybe it's the manual ways like feature subset selection or feature creation. The second strategy is numeracity reduction, or sometimes we can call it data reduction or instant selection. We have 1 million data. So I want to reduce to 1,000 data. So we can say this is the instant selection. We want to reduce the number of the data. There are some ways to do this reduction. We can do regression, okay, or log linear models, or we can use histogram, or we can use clustering, we can use sampling, or we can use the data cube aggregation. And the last one is data compression. Data compression, one example is the discretization. What you already learned before, we want to binning. Okay? So binning is one of the example about data compression. So let's see more details. Dimensionality reduction. Why do we need to understand this dimensionality reduction? There is the word curse of dimensionality. I don't know what is the Korean word, this one, but yeah, you can check. Curse of dimensionality. When we do the analysis, we want to make a good analysis. And when we want to make a good analysis, we want to collect many data as possible. But when the dimensionality increase, so it means when the column is getting a lot, data becomes increasingly sparse. So we cannot understand more. So in my research about the human activity recognition, the number of columns that I use, we have 500 columns. 500 attributes. And it's so complicated. We need to reduce it because not all attributes are important. And especially when we want to measure the distance or we want to check the density, which is critical to clustering or outlier analysis, it becomes less meaningful, not meaningful, because there are too many columns. And the possible combination of subspaces will grow exponentially. So if we try to analyze all those things, when they try to figure out one by one of each column, the time computation is very high. So the dimensionality reduction, it is to avoid the curse of dimensionality. This is the curse of dimensionality. And it helps to eliminate irrelevant features and it tries to reduce noise. It can reduce the time and the space required in data mining. And also, it allows easier visualization. You know, in the scatter plot, maybe if it is only one attribute, it is easy to see the data. If you have only two attributes, X and Y, it is easy to represent in the visualization. If it is three attributes, X, Y, and Z, now it's become a little bit complex. If you have four attributes, how will you show the visualization? If you have 5, 6, 7, you cannot easily see the data. Okay. So some dimensionality reduction techniques are wavelet, PCA, we call it principal component analysis, and feature selection. Wavelet transformation. It is a very basic idea of the transformation. It is discrete wavelet transform, or DWT, and usually it is for the linear signal processing, or it is for the multi-resolution analysis. For example, in the image, if you have image, maybe your smartphone is very good, you can produce a good image, but when you want to send the image through Messenger or through Kakao, if you use some other messenger in other countries like WhatsApp, the size of the picture should be less than the original picture. So it should be reduced. Okay. One way is discrete wavelet transform. It is to reduce the size, but the picture still show as it is. We call this with the compressed approximation. We store only a small fraction of the strongest of the wavelet coefficients. This is the method. Okay, I think I will just explain how the wavelet decomposition works. So the most popular picture is this one, this lady. You may have a big picture like this one of this lady, but how if you want to reduce this size into the smaller size, but you can still see it. So we can use one of the ways is the wavelet decomposition. I think I need more time to explain these details. I will stop here now. I think it will be better. So